Hope all of us are doing great. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. I'd like to request our members to kindly go to YouTube, search Ernest Sciences and Mathematics TV channel. Subscribe and engage us in the comment section, and also ring that notification bell so that we can be getting updates on various uploads that we do in various subjects. So we're going to come across various topics that we do in mathematics, physics, chemistry, and biology, and some of the application areas perhaps in terms of a problem set. So today we're going to look at the concept of differentiation of trigonometric functions. And basically, I'm going to do a short video on the concept of the cot over x. Now, from the three basic trigonometric functions we have for the sine, cosine, and the tangent of a function, we're going to see that the cot of x represents basically this specific representation. We had said that we are going to have the tangent over x given in terms of the sine over x all over the cosine over x. So therefore we are going to have this basic function for the tangent or the inverse of the tan over x given in terms of the cosine over x all over the sine over x, and this basically implies the cot. So we're going to do away with this. So this implies the cot or defines the cot function, as we have said. So basically we're going to rely on this specific representation for us to find the derivative of this specific function. So if I might have it in terms of an illustration, we're going to have it given as the d over dx over the cot x, and this implies d over dx, the cosine over x all over the sine of x given in that specific order. So for us to evaluate this particular equation, I'll try to show that basically we can have a representation for the differential or the derivative of the cot over x. We're going to employ the quotient rule, which discussed in our previous videos on the concept of two functions. So in that particular discussion, I said that we had a theorem that said that if g and f are functions that are differentiable at x, and f over g, for rather we are going to have and g of x, which is basically the denominator is not equivalent to 0. So if the denominator is equivalent to 0, especially when we have what we call a quotient, then therefore that function is undefined. So we are going to set this condition that if we have the two functions g and f as functions which are of course differentiable at x, and g of x is not equivalent to 0, then we are going to have f over g, which is a quotient, is differentiable at x, and we are going to have f over g prime given in terms of gx f prime over x minus fx g prime over x, and then we're going to have the law of this all over the square of gx given in that specific order. So in this case, if we are going to have a function that is going rather trying to assume this analogous form of a quotient, just similar to the one that we're going to have for the ratio of the cot over x, which is cosine over x over sine of x, we can employ the quotient rule in order to find the derivative of this specific function. Therefore, we're going to have this one given as a d over dx. So we're going to choose which particular functions represent the cosine over x and the sine over x in this specific order. So in my case, I'm going to choose f to represent the cosine over x and g to represent the sine over x in this specific order. Therefore, we're going to have the derivative of this particular function represented in terms of gx. I said gx is represented by the sine over x, so I'm going to have the sine of x given as such, and the derivative of the cosine over x, which is our f over x, is going to appear in the form of a negative the sine over x given as such, and then this is of course found with the minus function fx. So in this case, for me, the fx represents the cosine. I'm going to Okay, this is going to represent the cosine over x, and then I'm going to have this one in terms of the g prime over x given as such. Now my g prime of x, so I'm going to do away with this. So my g prime of x basically represent so this f over g prime over x. So my g prime of x is going to represent the sine. Therefore, the derivative of the sine, this implies the cosine. So therefore, this is negative the cosine over x, which is the function fx. And then therefore, we're going to have this one as the cosine over x, as the first the derivative of g of x, of course, which represents the sine over x, as I've mentioned. So this one is going to be all over g of x. So I said that g of x represents the sine over x. So therefore my denominator is going to be given in terms of the square of the sine of x given as such. So the evaluation of this specific representation for the this section of the equation on my right side therefore represents the derivative of the cot, or rather the derivative of this particular function of the cot over x as I said. So this is going to be given in terms of a negative the sine, the square of the sine over x minus and so this is going to be given as well as the cosine, the square of the cos over x all over the square of the sine of x given as such. So we can do a rearrangement of this specific equation by using the concept of an identity, whereby we are going to have this one given as a positive sign, but we are going to introduce a negative this specific process, or rather given perhaps in terms of brackets outside this sign, so that this is going to assist us in order to simplify or simplify this specific evaluation. So this is equivalent to we're going to have this one as -1, whereby this one implies the identity that for this trigonometric function that we've come up with, and then we're going to have this the sine of the square of the sine of x given as such. So we have said that basically for the sine or the inverse of the sine represents the cosec, and this is going to be the square, the negative square. So this basically gives us negative the cosec, the square of the cosec of x as our product for the derivative of the cot of x given in that specific respect. So this is how we can apply the various aspects of the quotient rule, the product rule, and perhaps the reciprocal rule in finding various trigonometric functions of this specific function for the cot, cosec, and the cot, as I've said. And of course, these are going to be more handy, especially in our application areas for finding differentiation values for trigonometric function, as I've said. So that is it for now, guys. By God bless you. Catch us in our next video.